Good morning. My name is AZMIENA binti AHMAD, and I from food security student. Today I will be presenting my bioscience topic, which is disease-resistant rice development for food security. Okay, for the summary, the bioscience problem I selected is the challenge of maintaining stable rice production due to plant disease that affect rice crops. To solve this issue, bioscience research used biotechnology methods to develop resistant rice varieties. This approach includes genetic analysis, marker assisted breeding, and molecular biology technique to identify resistant genes and improve rice plants. Studying this bioscience problem is important for several reasons. First of all, strengthening food security. Food security means ensuring that people have continuous access to safe and sufficient food. When rice disease reduces crop yields, food supply becomes unstable. Disease-resistant rice helps maintain stable rice production and reduce the risk of food shortage. Second, reducing economic losses for farmers. Plant disease can cause farmers to lose income because damaged crop produce lower yields. Disease-resistant rice varieties help farmers maintain productivity and reduce financial losses caused by crop failure. Today, I will explain my bioscience model on disease-resistant rice development for food security using a weekly field assessment from week 1 until week 14. But we highlight it from week 1, week 5, week 10, and week 14. Okay, at week 1, the infect leaf area is only 2.84% and spread velocity is 1.16% per week. Okay, this shows the infection is still small. The bacteria are just spreading. The bacteria is just entering the plant's vascular system, and the plant's natural barriers are still controlling the spread. Okay, for week 5 is infection increased to 11% with the velocity of 2.60%. This is still a peak phase where disease spread quickly under tropical conditions. For week 10 is infection increased to 23%, but the velocity dropped but but velocity decreased to 1.70%. This confirms the disease is losing strength due to plant immune response. For week 14 is a final stage. At week 14, infect area slightly drops to 24.68% and velocity is negative 1.80%. This confirms that the disease is now under control. The resistant rice variety has successfully activated its immune system and reduced infection spread. Overall, this graph shows disease spread, but it's gradually controlled by genetic resistance in rice plants. This demonstrates the importance of biotechnology in improving food security in Malaysia. One recommendation to improve this HTML website is to include more interactive elements such as animated diagrams, however, over explanation or a disease comparison chart. For example, users could click a rice disease image and immediately view symptoms, impacts, and biotechnology solution. In conclusion, disease resistant Development is an important bioscience solution that contribute to food security, sustainable agriculture, and improve crop productivity. Through bioscience and biotechnology, research can create a stronger food system and support future food sustainability. That's all from me. Thank you.
Assalamualaikum. My name is AISHA NABILA. Today I will present my project called Agro Product Biocalculus Simulator. This project focuses on the growth behavior of the MD2 pineapples and how calculus can help determine the optimal harvesting period. So this is the homepage of my simulator. This simulator combines biology, agriculture, and mathematics into one interactive system. So the bioscience problem I choose is determining the best harvesting time for MD2 pineapples. In agriculture and food processing industries, harvesting too early or too late can reduce food quality, sweetness, size, and also shelf life. Farmers need a way to predict a pineapple growth accurately, so this simulator models pineapple mass growth over time using a logistic growth equations. So this problem is important because pineapple farming is major agricultural activity, especially for food production and export. By understanding the growth rate, here, uh, farmers can improve harvesting efficiency, reduce waste, improve fruit quality, and also a better plant food processing operations. This project also demonstrates how calculus can solve a real biological and agricultural problems. So this formula right here, as you guys can see, this equation called the logistic growth model, it is used to represent biological growth over time. So this one here, L, represent the maximum biological weight or carrying capacity of the pineapples. So the K here is K represent the growth velocity, which control how fast the pineapples grows, and the x0 here represent the inflection point, which is the time where growth become the fastest. So you guys can see the graph here. The graph starts slowly, increase rapidly, and finally slow down again as the fruit approaches maximum size. So then the derivative right here, uh, the derivative equation calculates the instantaneous growth rate. In a simple terms, it tells us how fast the pineapple is growing at a specific day. So when the derivative value is high, the pineapple is growing rapidly. When the derivative becomes smaller, the growth starts slowing down. So the highest point on the derivative graph represent the fastest growth period. So I have three sliders here. The first sliders control the maximum biological weight. So when I increase this value, the pineapple can grow larger. And the second sliders is controls the growth velocity. So when the value increases, the pineapples grows faster and the curve becomes steeper. So the last one is the changes inflection points. This changes the day where the pineapple reaches its maximum growth speed. So back to the graph. Um, I click here. The simulator calculates the growth rate at a specific day. For example, here is the 99 day. So the tangent line here represents the slope of the curve, which is the derivative. At around day 99, the slope becomes steepest, meaning the pineapples is growing at its fastest rate. So one improvement I would recommend is adding more visual guidance for users. For example, adding tooltips for formulas, adding labels or animations, and adding clearer graph explanation for beginners. This would make the simulator easier to understand for users who are not familiar with calculus. So in conclusion, this project combines bioscience, agriculture, and mathematics to solve a real-world harvesting problem. It demonstrates how derivative and growth models can help improve agricultural decision making. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZULFADHLI bin MUHAMAD, and today I will present my project, which is the Bioprocess Calculus Simulator. This project is developed to help users understand bioscience and bioprocess concept through an interactive HTML-based simulator. The chosen bioscience problem in this project is the difficulty of understanding complex bioprocess calculations and simulation in biotechnology studies. Many students face challenges in learning mathematical models, microbial growth, and fermentation process because the calculations are complicated and difficult to visualize. The simulator helps simplify this concept using interactive features and graphical explanations. Studies on bioprocess simulation also show that simulation tools are important for improving understanding of fermentation and bioprocess system. Studying this bioscience problem is important because bioprocess engineering is widely used in biotechnology, food production, pharmaceuticals, and environmental industries. Understanding bioprocess calculation can help improve production efficiency, reduce costs, and optimize biological systems. In addition, simulation technology can make learning more effective by allowing students to explore process interactively without relying only on theoretical explanations. When clicking each point in the HTML simulators, user can view explanation related to the selected by process topic. Each point represents important information such as formulas, graph, simulation parameters, or biological process descriptions. These interactive elements help users understand the relationship between calculations and real bioprocess application more clearly and effectively. One recommendation to improve these HTML projects is to add more interactive animation and data visualization such as real-time graph, process flow diagrams, and simulation outputs. This can make the simulator more attractive, user-friendly, and easier for students to understand complex bioscience concepts. Thank you.